Hello, so today we are doing this problem called given two strings s1 and s2, we want to write a function to return true if s2 contains the permutation of s1. And so basically one of the first strings permutation, which is one of s1's permutation, is a substring of s2, the second substring, the second string. So for example here AB is s1 and this here is s2. And we can see that a permutation of S1, which is BA, is in S2, right? And so we want to return true if we can find a permutation of S1 that is contained in S2. So this one returns true. AB is not in this string here. There are only two permutations we can do here, AB and BA, and so none of them is here, so return false. As for the conditions, we get that both input strings are only lowercase letters, and this is always when the input says that it will be alpha lowercase letter, we need to keep that in mind because that often can help us reduce the time complexity or the memory, also the space complexity, sorry. And then both strings are in this range, right? Okay, so how can we think about this problem? So one thing we know about if it's a permutation, so there is certainly the brute force method that we can do, which is just generate all permutations of a string of S1 and check if any of them is in S2. But our constraint here says that the length of S1, let's just note it as this, and the length of S2 can be are in this range here, so it can be really big. So this brute force method would probably get time limited exception, so we don't want to do that one. So how can we make this better, right? So let's see. We can think about one other solution we can think about doing is the following. So we can think about, so let's say we try to sort them, right? So if we know that if we sort S1, so we can, so this is also, so let's say this is solution attempt 1. Our second attempt can be, let's try to sort S1 first, right? And then so we have sorted S1, and then the second step would be to check every substring of S2, or let's say take every substring of S2 that has length S1, length equal to the length of S1. Let's call that one sub, right? Sub S2. And then check if sorted S1 is equal to sort sub S2. So that means basically that there is a permutation of S1 that is equal to this sub S2, right? And so if that's true, then return true. Otherwise, keep going. If you don't find any that has this condition, just return false. The end. None found, return false, right? So the way we can generate substrings here for S2 is just by starting at I, right? So just doing a for loop. So the way we can do, let's call this A. So to do A, we can just take an I from 0 to the length of S2 minus, of course, the length of S1, because the strings that we are looking for are substrings of length of this length, like the S1. And we can just take S2 starting at I and ending at I plus the length of S1. And basically just sort that and check if this is equal. So if this is equal to sorted S1, just return false. You can just return false if that's the case. Return true, sorry. That's what we are looking for, right? Because that means that a permutation of S1 can be equal to this substring, and then at the end return false, right? But this also will probably TLE, because if we get a string that is 10,000, this here is over squared, and so we will get a huge number, and so this also will probably get TLE. So how can you improve on that solution? So one way we can improve on that is thinking about what we did here. What are we interested in? All that we want, and that we accomplish it with this sorted set, is that we want the characters that occur in S1 to occur in S2 in the substring of S2, and that it's the same number of occurrence, right? So basically, if we have an A in S1, in that substring that we are trying to match, we need to have the same number of A's. And if there is a B in S1, we want in that substring to have the same number of B's. So this is the only thing that we are looking for in order to find them, to say that a permutation of S1 is is that substring, right? And so let's see how can we accomplish this basically. So the way we can do this here is by trying a map, right? So we can just use a map, and the way we would do that is we can first. So the first step we can do is just construct a map of the number of occurrences of characters in S1. So that's the first step. So let's call this one S1 map. Then the second step would be to go through S2 trying to find a match. So, but before that, let's construct S2 map that initializes to the number of occurrences of the first, let's call n to be the length of S1, the first n characters of S2, right? So that way we can start comparing, and then after that we can just go through S2, and every time check if go through S2 like by substrings of length n, because we are trying to match with S1, and check if the map corresponding to that substring matches S1 map. And by matches here I mean just so by matches I mean that matches means just that for all C in S1 map C equal to S2 map C. So basically we mean that all characters in S1 occurred the same number of times in the substring that we are looking at and we are putting in S2 map, right? So one thing we can do here is we can go through the substring of S2 like we did here, and every time recalculate S2 map, right? But that's terribly inefficient because each point, let's say this is S2, right? And we are trying to go through it. And so we were here, and we were at this substring here, let's say. We're at this substring. Now we want to go, since we found that this substring doesn't match, let's say we found this substring doesn't match S1, so it's not a permutation. S1 is not a permutation that is equivalent, doesn't have a permutation that is equal to this substring. So we want to move to another substring, let's say this one. There is there is a waste of trying to recalculate S2 map for this entire substring, because S2 map is just the number of occurrences of characters. And so the only thing we need to do is, we know that this character is no longer in our S2 map, so we need to just decrement the number of occurrences of that character, and we know that this new character is just needs to be counted in S2 map, so we need to just increase the occurrences of this character. And so you can see what I'm doing here is very similar to a technique called sliding window technique. I'm just moving a window, and I'm updating it by just doing two operations: discarding the value that was in the window and is no longer in the window from my what I'm calculating, which is S2 map here, and adding the new value that the window moved to into this thing that I'm calculating. And so we can apply the sliding window technique. So that would be our fourth attempt, which is really optimal since it will do only O(n) stuff, O(n) operations here, because every time it adds just two values, right? So that one would be the same as this one, except we are not recalculating S2 map each time. We are just updating by taking into account the new value that we moved to and discarding the value that we moved away from. And so let's get into it and let's try to solve it that way. So what we said is we need S1 map and S2 map, right? So that just have the occurrences of them, right? So let's say, let's count that. So let's say S1 map, which is a collections, it's just a map. And I'm just going to do this, and this just allows me to not need to check if a value is there to initialize it. It just gets initialized to 0 by default. And S2 map, also the same thing. And so what I said first is I need to construct a map of occurrences in S1, and so let's do that here. So that would mean for C in S1 map of that C increased by 1. And so I didn't need to like say first S1 map equal to, like say if C not in S1 map, do this equal to 0 to initialize it, because I already did this default dict, which essentially does this for me. So I can just, both cases, if it was there or not there, can be handled at the same time with this. And now I have my first step here. Now let's see how can we, I need to do the second step, which is initialize the number of occurrence of characters of the first n characters of S2, and that's n is the length of S1. So let's do that one. So this one is step 1, and then step 2. And so for my step 2, I'm just going to go through the first n characters of S2 that I said here. So that would be the length of S1. Maybe let me just do n, I can just do it that way. So it's the length of S1. And for that, I need to say S2 map C is, we have a new character. So we initialize to the number of occurrences of that. And then after that, I'm going to do my window here, since I'm using the sliding window technique. So that would be I and J, right? So I'm going to initialize my I to 0, right? And J, we said it's, since I already initialized S2 to up to S1, so my basic window basically is going to be starting from here, with the first window already handled that I did here. And so that would be the length of S1, since I handled only the length of S1 characters. So that's like this. And my window will keep going until I reach the end, right? Which means that my J reaches the end. And so I will keep going until J reaches the end. And basically what I will do there is, so here I will check first if I find the match, and the match means just that the number of occurrences are the same, right? Which means that the maps are equal. And so if that's, then I return true. Otherwise, I keep trying to find a match by advancing my window. And so what are the conditions that I need to advance my window? So one thing is, if the value of I of S2I, which means basically the value here becomes, so let's say I'm moving my window, so if the value here is so if the value here at the start became so first I'm moving away from this window, right? So if I'm moving away from, so if I was here and I'm moving away, that means that my I, the occurrence of this character, needs to decrease by 1, and so my S2 map needs to decrease by 1, right? And now I'm going to check if the value is less than 1. That means that the character is no longer occurring in the window, so I can just move it from my map, right? So that basically I'm doing that so that this equality here can work. So I can just say dot pop to remove it, and I can remove the value here. Now I also moved my window. When I moved my window like this, I added this new character S2J, right? So I need to increase the occurrences of that character. So now my S2J should increase by 1, right? And then I need to increase the window. Since I did this, my I and J both increased by 1, so I need to do that. So I plus 1 and J plus 1, and then at the end I need to check if, like, say that there was like a permutation here at the end, and I exited my my loop. So I need to check that the last operation, in case this was like the match was at the last substring of length n, and so I need to check that by doing this. And yeah, that's all there is to it. So I'm moving the window and I'm checking every time if I have a match. Okay, so we have a problem here for okay, let's see, where did we make a mistake. Yep, we make a mistake here because our J needs to keep going until the length of S2, not the length of S1, right? Okay, so that's for this one, it passes. Let's see for this one. Okay, so that one works too. Let's try it. Okay, so this solution passes. Now we can improve this solution actually, because we are using a map here, but remember in the condition here we had that the input strings is only lowercase letters, and we know that lowercase letters have, so let's say this, let's look at this improvements. So lowercase letters are at most 26 characters, right? Sorry. At most 26 characters. And so what can we do with this knowledge here? So that means that we just need, we can replace, so we can replace the map with an array of length 26, because all we need is to keep the count of occurrences, and so we don't really need a map. We can just use an array of values that is indexed by the character value, since characters are at most 26. And so how can we do this? So instead of using an S2 map here, we can just use, let's say A is for S1, and, or let's call it S1 array, so that it's more clear. And let's define S2 array instead of the map that we did earlier. And what are these? So these needs to be just initialized to the value of the letter. So let me just show something quickly here. So ord of A, that's 97. If I do minus A, if I do minus ord of A, that's 0, right? Since I know I have only lowercase letter, if I do B, I get 1. If I do C, I get 2. If I do D, I get 3. So you get the idea. It will keep increasing. For A is 0, for B it's 1, for C it's 2, for D it's 3, for E it's 4. So for each character, it's kind of it's indexed in the if we indexed the characters in the order like A, B, C, D, E, F. And so if we do this, so for every character, we can just do this to get its index. So now we have an array that is 0, 1, 2, 3, 4, 5, and this is for each character in S1. So let's say, let me take an example here and show you. So if we do S1 equal, let's say if we do S1 equal to this, what would be S1 array? So it should be 0, 1, right? Yeah, there you go. Now we want to do the same thing for S2. And so let's take this as our S2 here. And let's check what S2 array would be. So because E, its index in the alphabet is 4, we get 4. E, I, it's 8. And you can see A here, it's 0. So basically this is like the indexing of the characters that we are going to use. And what is our, let's construct our target, like the value that we are looking for, which is basically the number of occurrences of characters in S1. So that's our target that we need to find. And so first, let's just initialize it. We know we have only 26 possible characters because they are all lowercase. And so let's initialize that. So for C in S1, we want target of C to be equal to be increased by 1. Basically, we are counting the occurrences of characters in A. So occurrences in S1. Let's call this. And now let's construct our window. But now instead of constructing our window with I and J, let's just construct it with the window we are at right now, which would be just the occurrences of the characters in that window, right? So this is just a different way to represent our window. And so same thing, we'll initialize it to this, and then we will, the window is in S2, right? We will start with the first window, which is this here, the number of occurrences of characters in the first n characters of S2. And so that would mean we will do, we can skip initializing it. We can just do that as we, in the loop. So we need to go through S2. And so we can just go through S2 like this. And the position at C, which just occurred, we need to increase its occurrence by 1, right? So go through S2 and increase the occurrence. And then just check if I is bigger or equal to the length of S1. That means we already have the first window set. At that point, we can just do the window, which is I minus the length of S1. Sorry, the length of S1. Yeah, the length of S1 array. Or we can just length of S1, right? So this is the start of the window, right? So this is, we exceeded S1, so the window is bigger now than the length of S1, which means we need to contract it so that we can get a possible, like a window that can be potentially be a solution. And so the way we contract it is by just decreasing the occurrences of this character. So that just essentially, let's say A was length, it was 3, right? And here we have our window became like 4. So that can be a solution. So we need to contract our window by moving I, only I and not J, right? So the way we move I is, we said this character occurs 1 less time than before, and we do that by doing -1. And we check if the window that we are looking at is equal to this now, because if it's equal to it, that means in the current window we have the same number of occurrences as S1, which means we have the permutation we are looking for. And so at that point we can return true. And then since we already did this for the value that the window is moving to, so we don't need to do anything. And at the end we can just return false, because we didn't find any window that is valid, right? And yeah, so that's pretty much all there is to it. And you can notice what we are doing here. This is just to get the index. The index in this, the index of the character in this array. Okay, so what do we have here? Yep, so I'm doing in S1, I want to do in S1 array to get like index values, like integers, instead of this, and same thing here. Okay, so that should work. Let's try it. Okay, so that passes, and yeah, so we used sliding window technique first with the map as an auxiliary data structures to help us keep track of the window and what we are looking for, and after that we improved it by using an array. And yeah, that was all for now. See you next time. Bye.